Hey, CPAD, I'm going to show you how easy it is and how quick to simulate liquid xenon detector data using NEST. So we are set up by just cloning the GitHub repository and compiling it, nothing else. We're going to use the LUX 2013 detector as our template, and we're going to simulate some calibration data. So let's start the timer. We're going to start by simulating tritium data. We're going to do 100,000 tritium events from 0 to 20 keV, which is around the endpoint. We are going to simulate that and put it in some text file. And for each of these events, it's going to simulate what is the light signal and what is the charge signal for each event. And then it's going to calculate just on the screen here. This is showing the electron recoil band, which is basically the correlation between the light and the charge signal. Now let's do this again, but instead of tritium, let's do DD. So DD is a nuclear recoil calibration source, and tritium is an electron recoil calibration source. We're going to do that again. It's going to simulate 100,000 energy depositions, and again, it's going to show the NR band now, the same band but for nuclear recoils. And finally, we are going to run this code called root nest, and I'll show you what that does in a second. It's going to take our simulations and it's going to calculate what is the discrimination between electron and nuclear recoils. We get 99.86%, and that compares to the actual measurement of 99.8%. So with reasonable error bars, that's a pretty good match, and that took less than a minute and a half, and that's with me talking. So really, it just took a minute.